Strong, flexible, secure. You can have confidence in Presto's Geoweb cellular confinement system. And when properly installed, the Geoweb system provides dependable soil stabilization solutions. Solutions for slope and channel protection, load support, and earth retention applications. The simplicity of the Geoweb system begins with the ease of unloading it. Sections are typically shipped from Presto, tri-folded on a pallet, and are easily offloaded with forked equipment. Start by preparing the site to construction drawings. Prepare a smooth surface, removing any debris or vegetation, and filling surface voids. On slopes and channels, excavate anchor trenches along the crest of the slope. When specified, install a geotextile over the prepared surface. On slopes and channel inverts, place the upper edges of the geotextile in the anchor trench at the slope crest and unroll it down the slope. In channels, overlap the geotextile in the direction of flow and secure it. On flat surfaces, expand the Geoweb sections and hold them in place with temporary or permanent anchors. To connect sections, align and interleave the sides of adjoining Geoweb sections so they're flush, then fasten them together with a pneumatic stapler. A stretcher frame keeps sections expanded when dimension tolerances are important on flat surfaces, such as for retaining walls, underwater applications, or in freezing conditions. Expand the Geoweb section so the end cells are hooked over the frame pins. Next, invert the frame and position the Geoweb section in place or next to an adjacent section. Once positioned, interleave the sides of adjoining sections and staple them together. Infill the Geoweb sections with specified material, removing the stretcher frame only after the section is backfilled. When anchoring sections at the crest of a slope, use a template with a series of cut V-notches located at every cell of the expanded section to simplify marking the stake position. Along the anchor trench or embankment crest, place an ATRA anchor where each Geoweb upper end cell is to be located. Presto's ATRA clips, used with ATRA stakes, form the ATRA anchoring system. Pre-assembled glass fiber reinforced polymer anchors are also available from Presto. To avoid hand contact with stray glass fibers, gloves should be worn when handling the glass fiber ATRA anchors. First, partially drive each ATRA anchor into position. Place each of the Geoweb upper end cells over the anchors, making sure the section will expand down the slope. Align the ATRA clip arm over the cell wall and drive the anchor until the clip comes in contact with the cell wall. Fully expand the Geoweb section down the slope, repeating the process for subsequent sections. Next, interleave adjoining cells of opposing sections and staple them together. Hold the sections in place at the bottom by driving anchors perpendicular to the ground. All stapling and anchoring can be done simultaneously. If the incline is longer than one expanded section, staple the required sections together before expanding them. When tendons are used, align tendon holes before stapling the sections together. Then thread the tendons after all the sections are stapled. After expanding the sections, insert an ATRA anchor within the top row of cells of each adjoining section. Drive additional internal anchors into the expanded cells as specified. The Geoweb system can cover odd-shaped areas, such as curved surfaces or corners, simply by altering the section. Two methods are used. For the first method, vary the degree of cell expansion along the length of the Geoweb section. Do this by under-expanding one side and over-expanding the opposite side of each section. For the second method, use a utility knife to cut the expanded Geoweb section into two pieces along a diagonal string line. Rotate or flip one piece and realign it with the other. Then interleave adjoining cell walls and staple them together to form the altered section. When tendons are required, use Geoweb sections furnished with pre-drilled holes. pre-cut tendons to specified lengths. Tendons can also be applied directly from the spool to the Geoweb section using the spool support system. With the Geoweb sections collapsed, thread pre-cut stiff or coated tendons through the pre-drilled holes. For uncoated, more flexible tendons, use a short, stiff wire with an elongated loop at one end to act as a threading needle. With the tendons threaded, position the collapsed section at the crest of the slope. Two typical crest tendon anchoring methods are as follows. Method 1 uses the ATRA anchoring system. Make sure that stakes can be driven into secure ground at the specified distance from the end of the Geoweb section and in alignment with each tendon location. Drive the ATRA anchors so the bottom of the ATRA clip is a small distance from the ground surface. Tie a non-slipping loop in the tendon large enough so it will fit over the ATRA clip. Then place the loop over the clip and secure it under the clip's arms. Method 2 uses a pipe deadman anchoring system. First, lay the specified pipe into its anchoring trench. Tie tendons securely around the pipe with a non-slipping knot to create resistance. Then pull firmly on the tendon to make sure the knot is secure. Next, backfill and compact the trench to secure the deadman anchoring system. For internal anchoring with tendons, place the ATRA anchors in the specified cells, removing any upslope slack. Next, fully drive the anchors perpendicular to the slope so that the arm of the clip passes over the tendons. Start from the uppermost cell and repeat the process for each ATRA anchor. For increased stability, secure the tendon with the Moore hitch. Place the tendon under one ATRA clip arm, cross it over the top and under the opposite arm. Then cross the tendon over the top again and pass it under the first arm. Some tendon types may require a double Moore hitch. When ATRA clips are used to transfer the load from the cell to the tendon, locate the cells where ATRA restraint clips will be placed. Starting from the uppermost cell and working down, remove the upslope slack from the tendon. Place the ATRA clip so it's against the upslope cell wall with the tendon passing under one arm. Next, secure it with the Moore hitch by crossing the tendon over the top of the clip and under the opposite arm. Then cross the tendon over the top again and pass it under the first arm. Moving down the slope, repeat the process for each ATRA clip, removing any upslope slack before tying the Moore hitch. ATRA restraint clips are typically positioned inside the uppermost cell and outside the lowermost cell of each section. When working on the slope is difficult or undesirable, ATRA restraint clips can be inserted in the cells of a fully expanded tendon Geoweb section on a level surface. Once all clips are in place, position the collapsed section at the crest of the slope and secure the tendons to the crest anchoring system. Finally, expand the pre-assembled Geoweb tendon restraint system down the slope. With the tendon Geoweb system, toe anchoring is similar to crest anchoring with the ATRA anchoring system. Tie a non-slipping loop in the downslope end of the tendon and remove the upslope slack. Place the ATRA anchor through the tendon loop and fully drive the anchor perpendicular to the slope so the loop passes under the ATRA clip arm. After Geoweb sections are secured for the application, infill is ready to be placed into cells with the appropriate earth-moving equipment. Make sure the wheels or tracks don't come in contact with the empty cell walls. On slopes, infilling is typically performed from the crest to the toe. Limit the drop height for all infill types to 3 feet for standard cells and 2 feet for large cells. If you notice any cell distortion, immediately reduce the drop height. Infill should be spread uniformly over the entire surface. Compaction requirements and equipment will vary with infill type. With many topsoils, place infill only to the top edge of the cells. Topsoils that require light tamping or rolling for stability should be overfilled 25 to 50 millimeters or 1 to 2 inches. Then tamp and remove excess infill so the soil is flush with the top edge of the cell walls. After the topsoil surface is prepared, Additional erosion control products such as liquid-applied mulches or tackifiers, straw, or erosion control blankets can be applied. With granular infill, overfill the cells 25 millimeters or 1 inch and compact the infill using suitable compaction equipment. If equipment comes in contact with the cell walls, add additional infill as needed. Generally, in slope and channel applications, excess granular infill is removed. Concrete infill can be placed into the cells directly from the ready-mix truck or from other concrete placement methods. On slopes and channels, concrete fill is placed from the crest to the toe to avoid downward cell distortion. Spread concrete evenly in cells so it's flush with the top of the cell wall. Then tamp it with manual or vibratory equipment. Finally, finish the concrete surface as specified. From construction start to finish, Presto works with you to provide solutions to soil stabilization problems. Cost-effective solutions you can rely on. You can rely on Presto.